Hello, I'm Paul Beckwith. In this video, I'm continuing my discussions on the tremendous risks that are facing New Orleans and Louisiana at the moment. As people are very aware of, New Orleans is below sea level, and at the moment the Mississippi River flooding, which has been ongoing and been record flooding, is expecting to crest with all of the rainfall that is happening in the region now, plus additional rainfall when this tropical storm, which will likely become upgraded to Category 1 hurricane, Barry, comes ashore on into this region on Saturday coming up. So basically that will also create a storm surge, and depending on the tide level, it will. There's some threat from the ocean side, from the Lake Pontchartrain side, but the biggest threat is from the Mississippi River cresting. It's expecting to hit 20 feet, which is the level of the protective berms. So it's going to be touch and go as to whether those berms can keep back the Mississippi River. So we could have a slow motion unfolding disaster occurring in New Orleans, similar to what we had before. So let me get right into the data. This website, Tropical Tidbits, is highly recommended. So I'm looking at, for example, precipitation moisture, 24-hour accumulated precipitation. That's what we're looking at here. And you can see most of the, there's lots of rainfall in the last 24 hours. The green levels, there's some blue up here. This is, this is in inches, I believe. Should have the scale somewhere. Looks like it is. Okay, so you can see this is a good site to track and to follow in the next few days to see the progression of the rainfall, that hits the city of New Orleans. There's lots of information that you can get here on lower dynamics of the atmosphere, upper dynamics of the atmosphere. For example, the jet streams here, okay, at 250 millibar. This is the velocity. The thermodynamics, so 2-meter temperatures, for example. Okay, 2-meter temperatures in degrees Fahrenheit here. There's actually lots of stuff you can get here, the temperature anomalies, etc. Analysis tools. Let's look at the ocean analysis, for example. Okay, you can get sea surface temperatures, globally, and look at the, we're focusing on this region here at the moment. Okay, I'll close this. Okay, so there's loads of, this is the current storm, and the projected path, and so on. So I highly recommend that you play around with this site as this storm continues to develop. Now on Twitter, I'm looking at the hashtag flooding. Okay, and there's lots of videos and images of what was happening in New Orleans this morning. Now, this is just from 5 to 7 inches of rainfall over the region. Like I said, with the tropical storm / hurricane Barry, there's projected to be, several feet of rainfall. So the ground is already saturated, and there's already significant flooding. So this is the cresting expected for the Mississippi River, 20 feet, and it's right on the borderline. A little bit higher, little bit higher, and there could be, major breaches of the levees from the Mississippi River going into New Orleans. This is French Quarter this morning. Okay, there's loads of videos and images of what's going on here. Okay, so And then this is Washington stuff here. Okay, so if we go to hashtag New Orleans, you can see more images and things. Let's see if there's some new things here. New Orleans this morning. I mean, look how high the water was just from that small amount of rainfall. So we're in a very, very risky situation right now. This is another hashtag. There was a water spout on Lake Pontchartrain this morning. You can see that there. This is the European model showing the serious rain flooding threat from what will soon be Barrie in eastern Louisiana, a stripe of 18 inches plus. So that would this here is 18 inches plus of rain, 1.5 feet of rain. Of course, it depends on the exact storm track as to what will actually develop. This is the latest European model forecast showing landfall Saturday. Okay, so this is mostly going to be a hydrology event. It's not the winds that are going to be the problem. It's going to be the rain that's dumped, also possible storm surge. Okay, so this is a section here on. Let's have a look at this. Okay, some images showing the the perfect storm scenarios that can lead up to Barrie are almost as bad as they can be, according to this tweet. Okay, there's also NOLA, the hashtag NOLA, lots of additional information on the flooding. Okay, from that, here's streetcars still running, powered by electricity, running through the water. What could go wrong with that? Okay, so this is mostly stuff that on the flooding that has occurred in this morning's event. Okay, so here's an image here's New Orleans from Google Earth. Okay, so and what's interesting here is you can focus closely on the city, zoom in on the city, and by clicking here and looking here, you can see the. Okay, now this isn't the relative value is good, but this is telling you as I move the pointer around. Okay, as you move, so if you look down here, as I'm moving the pointer around, it gives you the elevation, and you can see all of these negative numbers, so you can see all the regions that are below sea level. Okay, so also you can take the latitude and longitude coordinates, and then you can put them into Earth Null School, and basically get your location here. Okay, which is right about here or so, is the city. And I'm looking at the air, you can look at the surface, or this is a couple feet above the surface, winds, and now, okay, and this is what the storm is presently doing, and then you can project forward. This is going a day forward, and another day forward, and another day forward, and you can see how the forecast, and this is the GFS model, the storm is forecast to intensify in the Gulf of Mexico here over the very, very warm sea surface temperatures, and then curve to the right because of the Coriolis force and come ashore in New Orleans. Okay, so let's have a look at the sea surface temperatures. So if we go ocean, sea surface temperatures. Okay, and if we go now, this is the temperatures so what you can see is 31.4 degrees Celsius. Let's see if we can, you can look all around this region. Okay, so there's very, very warm ocean temperatures. These temperatures are more commonly this high in late summer, not in early summer. Okay, recall that any temperature above 26.5 degrees has enough evaporation from the sea surface to add energy to the storm. So any storm moving through this very, very hot water gains energy. That's why, that's why Barry, as the storm is moving this way and curving over this very, very warm water, it gains energy very, very quickly and is projected to reach up to category 1. And then depends on how the biggest factor is how long the storm takes to move ashore and to go and to dissipate over land. Because the land is very, very wet and saturated, there's lots of evaporation of that water that's sitting on the surface, and that will keep the intensity of the storm higher as it moves inland. I've called this the brown ocean effect in the past. So this is a problem. The big problem with Harvey, for example, over Texas and many of these other storms is that they linger. They kind of sit, sometimes half in the ocean, half ashore, and they just turn and they act as a big fire hose bringing water from the ocean to the land. So that's the biggest factor is to track in the next few days is how fast is this storm projected to be moving when it comes ashore. Because that huge amount of water that is expected to be dropped is a huge threat to New Orleans. Okay, so let's go back to air temperatures. We can look at the jet stream configuration. Okay, let's go back to, here's the New Orleans right here. Okay, you can look and see what the jet streams are doing. They're well up to the north in general. Go back to the surface temperatures. We can look at the mean sea level pressure and then extrapolate forward. Okay, we'll keep going. And the pressures, the pressure low, it doesn't get down to about 1,000 hexapascals, whereas this is 10, 12. So it's not the wind strength won't be enormous with this storm. It's the amount of rainfall that's really the key. So if we go to total precipitable water, you can see these levels here of water are quite enormous. Okay, very, very high levels of water in the air that can come down as precipitation from this storm. I just want to remind people that if you go to Google Images and look for water vapor and air versus temperature, you can get all kinds of different plots. And this is one of them that comes out. And the key thing is that warmer air, with warmer temperatures, there's more evaporation of water from the ocean, from lakes, from rivers, more loss of water vapor from soils, etc. So there's a lot more water vapor that goes up into the atmosphere. For every 1 degree Fahrenheit increase in temperature, there's 4% more water vapor in the atmosphere. 1 degree Celsius is 1.8 Fahrenheit. So for every 1 degree Celsius increase in temperature, or 1.8 degrees Fahrenheit increase in temperature, there's 7% more water vapor in the atmosphere. This water vapor rises up, condenses, forms the droplets of clouds, and releases huge amounts of energy. The latent heat of the water vapor is released, and that fuels these massive storms and extreme weather events that we're seeing. So warmer air obviously means more evaporation and more precipitation. Okay, so keep a close eye on this storm. Use the tools like Earth Null School, Tropical Tidbits to track what's going on in the next few days. But I think the risks are great. I think people in that region need to really prepare and treat this situation very seriously. So please, again, check out my website, paulbeckwith.net. Consider making a donation. And I want to thank everybody who has made donations. Thanks for listening. Bye for now.